Now the lines we want to look at, or the inequalities we want to look at, are a little bit more complex. It's just that we're not in the y equals or y is greater than or equal to. It's just a different form. So getting more towards a generalized form. So again, we follow the same process. Draw up our line. So when x is equal to 0, y would equal 3. So that's why it goes through 3. When y is equal to 0, x equals 1. We just solve that to graph our line. So we graph our line. We check whether it's equal to. So it is. So it's solid. Now again, test 0, 0. I'm going to test 0, 0 because it's the nicest one to test. So 3 lots of 0 plus 0. Is that greater than or equal to 3? Is 0 greater than or equal to 3? No, it isn't. So that means 0, 0 is not in our region, so we shade the other side. So the process stays the same. It's just making sure we graph that line properly, and we've done lots of practice over last year and this year about graphing lines. So this time 2x plus 4y less than or equal to minus 4. So again, when x is equal to 0, 4y equals minus 4, so it goes through minus 1. When y is 0, 2x is equal to minus 4, so x will equal minus 2. There's our 2 points. Draw up our line. It's solid. It's a solid line because it is equal to as well. Again, test 0, 0. And we see that we put 0 and 0 in there is not less than or equal to minus 4. So we shade the other side. So same process, we keep going through it. When x is equal to 0, y is equal to minus 8. So that's where we're getting through y is equal to minus 8. There's our point there. When y is equal to 0, x would equal 4. So we're able to substitute and we get 4, 0 there. Draw up our line. Make sure it's dotted this time because it's not equal to. So it's going to be a dotted line. Hopefully that's showing up okay for you. But it should be a dotted line there. And then we test 0, 0. Put 0 in there, put 0 in there. It's not greater than 8. So 0, 0 is not in the region. We shade the other side of the line. For D, again, put 0 in for x, we get our y-intercept. Put 0 in for y, we get our x-intercept. There's our 2 points. We're able to get our line. You could put any other point in. Put x in and get the y. Put x is equal to 1, get your y value. Or x is equal to 2, get your y values. That doesn't matter. It's just that putting the x equals 0 and y equals 0 for your intercepts is easier to do. So again, test 0, 0. Is 0 and 0. So 3 lots of 0 minus 0 is 0. Less than 6, it is. So 0, 0 actually sits inside the region this time. So we shade where 0, 0 on that side of the line. So make sure it's dotted as well because it was only less than. So the next one here again, it's less than, so it's going to be a dotted line. We get our points. When y is equal to 0, we get x is equal to minus 4. When x is equal to 0, we get y is equal to 5. So treat it like it was the equation of a line. Find your intercepts, draw your line between those 2 points and extend it. And then test 0, 0. Put 0 and 0 in there. It works out nicely with this one because we get 0 less than 20. So 0, 0 is not in the region. So it's not a problem. We can see that we must shade the side that 0, 0 is on. So that's why this side gets shaded there. And 3y minus 7x is greater than 21. Again, y is equal to 0. X must be minus 3. X is equal to 0. Y must be 7. So that's where we get our line there. It's dotted because it's only greater than. It's not equal to. Let's put 0 and 0 in there. That gives you 0 is not greater than 21. So 0, 0 is not in the region. We shade the other side. So the process stays the same no matter which way the line is and what form the line is in. Again, we just draw up our line, throw our points in to check which side of the line we're going to shade.